Hello everyone. Today we're going to be looking at how to do one sample t-test in SPSS. As a reminder, a one sample t-test is where we want to compare a sample to the population, and we know the population mean but not the standard deviation. If we knew the population mean and the population standard deviation, we could do a one sample z-test. But when that population standard deviation is missing, we would use a one sample t-test instead. Today we're looking at the class dataset for Psych 2231, Introduction to Statistics and Research Methods, otherwise called Design and Analysis 1 at Georgia Southern University. If we want to run a one sample t-test, comparing that sample to the population, we go to Analyze, Compare Means, and a one sample t-test. In here, we would put the variable that we're interested in. In this case, we're going to look at how many pieces of sports apparel people own, and we need to put in the population mean. That's what our test value would be. For this particular example, I started with a made-up population mean of 3.2. So what we're going to do is figure out if Psychology 2231 students own a same amount of sporting apparel as the population. That's the null hypothesis, HO equals 3.2. And then our alternative hypothesis or research hypothesis is going to be two-tailed, that Psych 2231 students might have a different value than the population. And with a two-tailed test, we're not specifying whether they will have more or less. We just want to see if it's different. We'll discuss after we run the test how you would make it one-tailed if you had a direction in mind. So we don't need anything in options in this case. We're going to go with the default confidence intervals of 95%, and we don't need to worry about bootstrapping. So all you need is your test variable from your sample and your population mean here as the test value. When you click OK, what you will get is a report of your sample size, n, your sample mean, your sample standard deviation, and the standard error. Remember, if we're comparing a sample to a population, in the denominator, if we were hand calculating, we would need to take the population standard deviation, or its estimate, and divide it by the square root of the sample size. So this is that standard error, or sigma sub m, that we have become used to seeing when we do one sample z-tests. Then it shows us the inferential results, the results of the one sample t-test. So we have the actual t value here, calculated with the degrees of freedom, which in a one sample test is equal to the sample size minus 1. So 223 minus 1 is 222. And this is the probability level that we get for the t-test we had. A high probability level like this means that we do not see a significant difference. Therefore, we fail to reject the null hypothesis, and we conclude that Psychology 2231 students own a similar amount of sporting apparel than the population. Remembering our population value was up here. Now, we can see how this changes if we had a different population mean. So if we ran this test again, and instead of saying the typical population person has 3 pieces of sporting apparel, maybe they have 1.5. In that case, if we ran our t-test, we would find a bigger t-value and a significant difference, suggesting that our group does have a larger amount of sporting apparel in their closet than the population. If we had a population value that was much bigger, let's say the average person in America had, 10 pieces of sporting apparel, and we could look at our class. So here's our population average. Then we would also see a significant difference, but that t-value would be negative, because what it means is that our group has a lot less pieces of sporting apparel than the population. So we can see by playing with a couple different numbers how those t-test results might change depending on what that population mean is. Now, again, this is a one sample t-test that is based on a two-tailed hypothesis. We were looking for places where our group might have had more sporting apparel or less sporting apparel than the general population. SPSS doesn't have a default way to do a one-sample t-test. So if we wanted to, a one-tailed t-test. So if we wanted to do a one-tailed where we thought, hey, psych students definitely have more sporting apparel than the population, and we wanted to hedge all of our bets to one side of the distribution, we would need to use the unit tables in the back of the book, right, to look up ones for t-values and figure out what that particular t-value would need to be for a one-tailed test. Sometimes I've seen online that they suggest just cutting the alpha level of 0.05 into 0.25, but that's going to make you miss a couple percents of people if you're hedging your bets on one side. So your best bet if you do a one-tailed test is to let SPSS run it. It will still calculate the correct t-value, but then you'll need to use the tables to figure out what that critical t-value is that goes along with your alpha level for a one-sample test.